So I'm going to try to take us all through the basic architecture that we're trying to build for this Binghamton University cloud thing or this Binghamton University HPC thing that we keep talking about. And I think there's a fair amount of confusion floating around in terms of what we're trying to do because it really is rather complicated and there's a lot of different dynamic needs that we're trying to address. But so I'll try to just build everything up from the beginning to the end, and then we can see where we're at. But effectively, okay, so we're building some kind of HPC thing. We're building some kind of cluster. So we're going to start with some hardware, some CPUs, some GPUs. Again, I don't really have all the details about what those are and how big they are and all of that kind of stuff. But for the sake of architecture, it needs to be there. And then on top of that, we add some kind of a physical network. Again, details are kind of irrelevant at this point, but we need some kind of physical networking. And then we throw in some storage. We probably want some faster storage for scratch space or whatever, and then probably some slower, longer term, longer duration storage or whatever. Again, I don't have sizes or speeds or whatever, but from an architecture perspective, obviously we need to have some sort of storage. Um, and then we've talked about this a fair amount, right? So we've got a whole bunch of hardware here. We need to be able to manage it in some capacity. So we throw in some kind of hardware management software or tool or whatever. We've talked about Bright Cluster Manager quite a bit here, and so that probably makes sense. And then on top of all of that, because we're building a cluster, we want to be able to submit jobs. We've got a job scheduler, and we can use Slurm or whatever. It doesn't really matter, but some kind of job scheduler where people can submit their jobs into this thing, and then they get deployed and run or whatever, and then the person gets notified when they're finished, right? I mean, relatively straightforward stuff here. The problem is that we already have this. I mean, Binghamton University pretty much has exactly what I've just drawn here. It's called Speedy. It's an HPC cluster that's run by the Watson School of Engineering. It sits at like 80 or 90% capacity, and it pretty much meets all of the needs that I've just built here or that I've just drawn here in this drawing. So I don't want to build this because we literally already have this on campus. If we were to build this again, we would be replicating infrastructure that we already have, and really we wouldn't necessarily be helping anybody. Now, there's one thing that some researchers have talked to us about, and really actually I'm talking about one researcher, where they can't use Speedy because they are doing research on hypervisors. And you can't really run a hypervisor on top of a hypervisor, so you can't simulate this with VMs or whatever virtual environments. So they need the ability to dynamically be able to deploy separate operating systems and different kernels onto physical hardware. And the Speedy cluster does not allow you to do that. So the ability, and really what they've asked for here, is for some mechanism where they can go into some interface, and maybe that's Bright or whatever, and deploy a custom kernel and a custom operating system onto some of the hardware within the cluster. Now that kind of starts to break things because now your job scheduler is not able to deploy these things, jobs universally across all of the hardware, because some of your hardware is running completely different infrastructure, or completely different kernels than the rest of your hardware. So it's kind of a wonky situation, and it makes sense why it doesn't work currently within the Watson cluster, the Speedy cluster, but that is what they have asked for. So, I mean, if that makes any sense. Okay, so, but really, though, I mean, if we build that even, what we've effectively done is we've helped one researcher, because the researchers that actually need something standard can already use Speedy, and then we've got this other researcher over here who wants to be able to deploy custom kernels, but that's it. We haven't solved data science at Binghamton University. We spent a lot of money, and we haven't really built something which is going to actually aid in the research infrastructure of the campus. So I'm going to move the job scheduler stuff over to the right-hand side. The basic cluster stuff, we're going to kind of put that on hold for a moment. And instead, I'm going to throw in a whole bunch of virtualization stuff. So we, on top of our physical hardware and our physical network, we're going to throw in a hypervisor, whatever that ends up being, KVM. I mean, obviously, there's a whole bunch of them. Some kind of software-defined networking, virtualized storage. And then we need some kind of an API management layer that sits on top of all this stuff so that you can dynamically provision and reallocate all of these things on the fly as needed. And why is it that we're doing all this stuff? Obviously, this is adding a tremendous amount of complexity to the whole thing. Well, that's because ultimately, the vast majority of researchers at Binghamton University, what they are looking for is some mechanism where they can request by themselves through some management portal or some kind of management dashboard, a server or 10 servers or 100 servers of dynamic size, be able to spin them up, tear them down. Somebody might want just be able to run Excel with a ton of RAM associated with it. And so they might want to be able to spin up a Windows VM, like what we've got over here on the left-hand side, where they have a ton of RAM and a ton of CPU associated with it. And they may want to only run that for 2 hours or something. So that's where the whole virtualization thing comes into play. Similarly, you might have a bunch of researchers who want to spin up a whole bunch of Linux VMs or something like that for whatever they're trying to do. There's a whole bunch of use cases here. I can't really go into all of them in detail, but really, from an end user perspective and from a researcher perspective, the ability to have researchers be able to go in and spin this stuff up dynamically as needed with custom operating systems, with custom configurations is absolutely what they need in order to be able to address their current needs. And the way that they're doing that currently, which is what we want to kind of replace, is these are the same people that are going to Best Buy and buying servers there, or buying custom stuff and leaving it in their office under their desk. So we would like to be able to replace all of that custom stuff, that custom hardware, and be able to put it inside of these virtualized containers and allow people to spin stuff up that effectively replicates what they were doing in their own office. And so I've mentioned OpenStack quite a few times, but the reason I've done that is because that is effectively what OpenStack is it's this cloud management platform. It comes with the virtualized storage capacity. I mean, obviously it's all part of the stack, some kind of hypervisor, some kind of software-defined networking, and then it's got this really nice dashboard interface called Horizon, which allows you, or really end users, researchers, to go in and be able to provision all of this stuff without necessarily having to do command line everything. Now, this is kind of similar to what we have currently at Binghamton. Mike Kisney's team uses VMware to do a lot of this kind of stuff. I don't know that they have the same level of virtualized networking and some of that, but that infrastructure is really kind of inappropriate for researchers because that's really the stuff that's built in order to run things like Binghamton's SIS, our banner instance. And so giving researchers the ability to actually go in and start mucking with things is totally kind of inappropriate for something like this. So it's similar to what we have in that space, but it's really not the same thing. And so then what can you do with this? Well, if you wanted to, you could theoretically spin up a virtual cluster inside of the VM environment, right? So you could spin up a whole bunch of Linux VMs with a whole bunch of different operating systems. You could theoretically install your own job scheduler, and you could build your own virtual cluster. And then this is where things get a little bit dicey, but also in theory, you could provision out certain VMs and be able to do work with controlled unclassified information, NIST 800-171, 853, and really build, firewalls, not necessarily networking firewalls, but firewalls that allow this stuff to exist in the same environment. Now, I'm not totally convinced about this just from an auditability perspective, because I don't know that I trust our end users to be able to have full control over this environment and then build something which is compliant with 800-171, just because I think that that's something that they theoretically could do, but in practice, not necessarily from a technology perspective, but from a management perspective, may not work properly. And then finally, because we're going into our wish list here, we've now got some hardware that is kind of set aside for physical things, so we can deploy physical infrastructure, and then we've got some hardware that's set aside for virtual infrastructure. And it would be really nice if we could kind of share those resources dynamically, such that if somebody's not using the dedicated physical hardware, that could be handed back over to the hypervisor and it could be deployed into the virtual environment. And if people aren't using the virtual infrastructure, that could be shared over into the physical environment and then be able to use there. I haven't seen anything that would allow for that to happen, but that is one of the requests that have come up as part of building this whole infrastructure. So that's what this thing looks like, right? I mean, we're trying to address multiple needs here. We obviously have a need for secure storage, secure compute. That's what this whole thing is up here. We have a whole need for standard virtualization of environments, We have a need for doing remote desktop with like Windows VMs and things. That's kind of I think what we had over here. Obviously in storage, but it could be or in secure, but it could theoretically be like an insecure RDP environment. And then we've got this request for the ability to deploy custom hardware or custom operating systems onto the hardware itself, not inside of a virtualized environment. So we're really addressing multiple needs here, and I think this architecture, if it's possible to build, would address all of the needs that have been raised as part of this data science initiative. Now, if we're getting realistic about some of this stuff, I think that possibly we have to start pulling this thing out into separate environments. And so that's kind of what I've done here. If we go back and forth, so effectively, I've taken the mini cluster that we had, where we're dynamically provisioning hardware, and rather than having that be part of this other OpenStack thing or this cloud environment, it may make more sense to pull that thing out as its own little baby cluster that sits kind of off on the side. Obviously, that completely removes the ability to do the shared resource between those two things, but from a actual implementation perspective, that might make more sense. And then similarly over here with the CUI data, this 800.171 data, while I do think it might be possible to be able to take all of that and mix it in with everything else that we have, it probably makes more sense, or it may end up making more sense, to pull that out into its own stack over on the left-hand side here, where we've got kind of a clone of the cloud environment of that virtual environment, but with a specific focus on controlled data. And probably we would lock down a lot more capabilities from an end user perspective, such that they can't go in and configure their software-defined networking. And then we have a lot more auditability and stuff like that we would be running in the background on the secure environment versus the other environment over there. And so effectively what we've ended up with here is we've kind of got a baby cluster, which is this very purpose-built cluster to meet that very purpose-built research of hypervisors. We've got our cloud cluster, which is the workhorse of this whole thing, which is where we're going to put all of these VMs and have all this dynamic capability for researchers to be able to spin up servers and remote desktop machines and all of that kind of stuff. And then we've got the secure cloud cluster over here, where we are putting stuff that's like 800.171. And while the baby cluster and the cloud cluster probably can use the same storage, just because it's the same data classification level, we probably, I'm guessing, are going to need to have some separate storage or some mechanism for segregating that storage into two parts, one for secure and one for everything else. So this is obviously probably more complicated than what I think a lot of people might have been thinking when we started going into all of this stuff. But in order to address those needs, I mean, and you can kind of see all three needs laid out here in front of us. We've got a need for secure compute. We've got a need for dynamic ability to spin up infrastructure on the fly in a very simple and easy capacity. And then we've kind of got this separate need, which is totally kind of separate than everything else, which is to do hardware level computational stuff with custom kernels in a purpose-built cluster. And when I've talked to other schools, like for example Cornell, that is effectively what they are doing here. They have their Red Cloud, which is what we've talked about before, which is this big middle one. They've got their secure Red Cloud, which is over on the left-hand side, which is more specific to the secure data stuff, the HIPAA data and all of that. And then they've got a whole bunch of baby clusters that are built specifically to meet a very specific researcher's need. And so this baby cluster happens to meet this one particular need that I identified, but it would kind of, in theory, make sense that if you're not going to use the speedy cluster, which is kind of the generic cluster, it may still be required to build up these little one-off baby clusters that are very specific to a particular researcher. So I hope that helps. I hope that helps us better understand what it is that we're trying to do, and some of the thought that's gone into the architecture, and why we keep coming back to this notion of cloud and OpenStack and all of that. Because really, at the end of the day, this middle piece is probably the biggest demand as it stands now for Binghamton University. And so if we aren't able to address that need, and we're really kind of get too focused over on this other stuff over here, we won't actually have an environment which is usable and productive for researchers at Binghamton University. All right, thanks.